Okay, we'll do the final two examples that we had set up in the last videos. The scheduling problem with the post office. I'll show you how to code that one up, and we'll also do the flow problem with capital budgeting. Each of them has maybe something extra that I'd like to show you about the capabilities of coding these up with OMPR in R. So here's the post office problem. I'll maybe refresh our memory and scroll to what we had in the notes. Our formulation was we had a decision variable for each of the days of the week, and each of these decision variables represented the number of workers starting on that day and then working 5 consecutive days, because remember, the union says you work 5 consecutive days and you get 2 days off. So we got to follow the union. And so that's how we set up our variables to essentially take care of that constraint. It seems like it should be a constraint, but by cleverly coding our decision variables, we don't have to explicitly write a constraint to do that. Now our objective is that we want to then minimize the total employees. What's the fewest number of employees that we can have in order to cover all these shifts? So that's going to be our objective. Constraints, we're going to get 7 constraints. And then we want to look at who's working on Monday. Well, if you start on Monday, you're working on Monday. But if you start on Tuesday or Wednesday, you're not working on Monday. And so we don't include those. But if you start on Thursday, Friday, Saturday, or Sunday, then you're also working on Monday. And so the sum of all the employees working on Monday has to meet the staffing needs of at least 17, right? We allow for there to be some days that end up being overstaffed. And that's likely going to happen in order to satisfy the union's demands of 5 consecutive days. We don't have the flexibility to have some people work 4-day or 3-day weeks, only full-time workers and only 5 consecutive days. And so likely we're going to have to overstaff a couple of the days. Same thing for Tuesday through Sunday as well. We're going to have essentially the sum of all the workers working on that day, which will be 5 of the variables, and it will be leaving out 2 of the variables because 2 possible start days are going to have their day off on that day. We'll have non-negativity constraints, and we're going to have integer variables. So that's the setup. Let's go ahead and code it up in R. So here we go. When you start getting to more than 2 variables, it's nice to use vectors to keep track of things. Here's how we can set up vectors in R. You use the C command and then set up parentheses, and you list out separated by commas the things that you want to have in your vector. And so here I've created a vector of days of the week to kind of keep track of Monday through Sunday. Chose to go Monday through Sunday instead of Sunday through Saturday to kind of match the order that they were placed in this table here. Here I've gone ahead and made a vector of all the staffing needs from this table. And then I went ahead and put names on that so that the staffing needs is named by the days of the week. This is a nice sort of feature here. I'll kind of show you maybe a little bit what that looks like. Here, let me put an extra code chunk in here to talk through this. So if I run that, and then if I look at staffing needs, it's now a vector where each of the elements is named as well. And so by giving them names, I can now, much nicer read this, but also I can then index and look at what are the staffing needs for Tuesday and refer to it by that name, and it'll pull out the Tuesday part of the vector, which is a pretty powerful trick in R. So this is sort of a little bit of setup, and then let's actually step through this model. Here, move this over to the side. So we're going to create an empty model and add variables. The trick here is that instead of adding the variables one at a time with a separate line for each of them, The OMPR library allows us to essentially specify a bunch of variables and add them simultaneously. And so I named my variables start on to remind me that what the variable is talking about is not the number of workers on a day, but the number of workers that started on that day. It's going to be indexed by the day of the week, and that day is going to go through the days of the week. Okay, so to sort of add multiple variables, you need to use then square brackets, which are how you index in R or access items in a vector or list. And we're going to index by here, this day runs through the days of the week vector, which are this vector up here. Okay, most of the time you're indexing by numbers 1 through n, or 1 through 100, 1 through 1,000, whatever your problem is. But in this case, I wanted to see if it's possible, and it turned out to be possible. You can index through a list of names as well, and that works. And all of these will get lower bounds of 0. I didn't double check whether I need to put type equals continuous or not. We'll see. We'll see. I'll do something to check that in a little bit. So we added our variables. We can add, and so we're adding a variable for each day of the week. Now we can set objective, and it's got a helper function here, which is sum over. Sum over does what it sounds like. It adds up all of the start on days over the days of the week. So it's essentially indexes through the different days in the days of the week vector and adds them all up. So exactly what we want, because we want to add up all of the days of the week. And then we need to give a direction to our problem, and so it's going to be a minimization problem. So we want to sum over all the employees that start on the different days of the week. Next, we'll go ahead and add the constraints. Okay, this code is maybe not the most readable, but what we're doing here is, if we think back to here, we wanted to sum up, but we wanted to leave out Tuesday and Wednesday on this list. Okay, and now Tuesday and Wednesday are the second and third day in the week. And so what I did is we're going to sum over days. If we put negative indexes in there, they leave off those indexes. So this would say every day of the week except the second and third. Okay, and that sum over needs to be greater than or equal to the staffing needs on Monday. Similarly, when I'm looking at Tuesday's staffing needs, I'm going to sum over all the days, but this time I'm going to leave out days 3 and 4, which are Wednesday and Thursday. And that kind of keeps going down, and there's a nice pattern here. If you're a little bit clever, you could actually add all 7 of these constraints in one line. But I thought that got maybe a little bit too unwieldy and a lot harder to read. So I did 7 separate constraints, but you could do this as a single constraint in a similar way that we were able to add all the variables in one go. So I'll let you play around with that. If you want to dig into it and try it out, you could. So let's go ahead and run this whole chunk. This extract constraints pulls out the constraints in the model. And so here is what we call our constraint matrix. There's 1 column for each variable, 1 row for each constraint. And this one is essentially the coefficients of 1 times the first variable, which is that starts on Monday variable. And then the dots represent zeros, because this is a sparse matrix. It actually only records the non-zero entries in the matrix and kind of leaves empty the zeros. And so it's a 1 and a 0 for Tuesday and Wednesday, and a 1 for Thursday, Friday, Saturday, and Sunday. And you can kind of see it has a nice circular kind of wraparound pattern going through the constraints, which is pretty cool looking. All the constraints are greater than or equal to constraints, and the right-hand sides are exactly the staffing needs. Okay. In the library that I used to use, LP Solve, the way you'd actually set up your problem is precisely by providing this matrix, providing this direction vector, and providing a right-hand side vector. And so you had to sort of build each of those components yourself, which isn't the worst, but this MIP model, the OMPR library, allows you to do it in a little bit more readable way and has some nice utilities that help you build your constraints. So let's see. Here are a couple notes about R and vectors, but I think I've mentioned each of them as I was talking through that example. And now we're ready to solve our post office problem. And so if we run this, here we go. It looks like it defaulted to continuous variables. And so it says you need 22 1/3 employees, and 6 1/3 of them are going to start on Monday, 3 1/3 are going to start on Tuesday, and so forth. So not really the most useful solution, because I'm pretty sure the union would frown on dividing their employees into thirds. Yeah, so not going to work. So we can't have partial employees, so we got to go back and we got to change the type of our variable to type equals integer. And so let's actually grab that and put that back in here. So add variable, lower bound of 0, type equals integer. Go ahead and rerun that. And once you've rerun that, then we can rerun the solve step. And now it's giving us whole numbers of employees that start on each of the days. We can't get as low as the 22 1/3 employees, but we can do as good as using 23 full-time employees, with 6 starting on Monday, 6 starting on Tuesday, none starting on Wednesday or Friday or Sunday, 8 starting on Thursday, and 3 on Saturday. And so that will cover our staffing needs throughout the week. And if you do a little bit more digging, I won't go into it now, you can actually see, well, where do I have some slack in those constraints? What are the days that are I have more than enough workers on? So you can play around with that and kind of investigate that. That'd be an interesting question to ask, and it's definitely one that we're going to be interested in as we go on in the course. So that was the post office problem. I'm going to stop this video here, and then I'll jump into the capital budgeting flow problem.